All right, so after you're done with the Excel portion of Lab 1, the next step is to move on to R. Now, R really is the most commonly used, most powerful statistical and simulation modeling language or tool that we use as ecologists and wildlife managers. And in some ways, it's kind of a shame that the whole class basically isn't in R. Because if you can master R, you can not only analyze data collected in the field, but you can visualize that data, you can communicate the results of your models, you can do forward simulations to understand the implications of your new understanding of a system for what might happen hundreds of years into the future, for instance. So you have so much power at your fingertips. So in some ways, I wish we could, use R for everything in this class. But I will say that it's a bit of a learning curve too. So you'll find it takes a little time to get comfortable with R and to really start using it to solve complex problems. It just takes time, and this isn't a programming class. This is a population ecology class, and I'd really like to focus on the concepts as well. So I don't want you to get bogged down in computer programming when really what we're trying to do is internalize the basic concepts of population ecology. That, I think, is a task that Insight Maker is probably a better tool for because it's much easier to get started and to use. So that's why we use Insight Maker in the class more than we use R in just because of this practical reason. But I would totally encourage you to work with R throughout the class, and we will be using R on and off, especially in labs. And so I want to give you as much experience as you can get in R, but I also don't want you to get too bogged down and frustrated. So here we are. Let's do a quick intro to using R, and specifically using R for population modeling. And we'll have plenty of times to return to it, and don't feel too upset if you don't get everything right away. You probably haven't done programming before, so this is a big ask for you to do population modeling. We're going to ask you to do some simulation modeling right away for this lab. So we're here to help. Let us know if you have questions. Otherwise, let's get started. So I would first recommend that you take a little time to just open up R and play around with the basic features and functionality. Don't feel like you have to get started with the lab right away. We have 2 weeks to complete this lab, so don't feel like you have to finish it right away. There's lots of great resources in the web for learning R. First of all, I think I already gave you the links, but make sure you've installed R in RStudio. They're free, easy to install, and pretty easy to get started. So let us know if you have any questions with the installation, but otherwise, let's move on. There's lots of great resources in the web for learning R. So feel free to go and find resources that work for you. If it's helpful at all, I have a bunch of resources that I've put up on the web that I call the UNR R Bootcamp series. I've put all the R Bootcamp resources on Web Campus as well, but you can also reach them using, this is not the right link. I'll update that link, but this is the real link. It's kevintshoemaker.github.io/r-bootcamp, and I'll obviously link to that through Top Hat, and I'll link to that through Web Campus. And so this is a more or less painless introduction to R. This is kind of the get started module, but if you want to keep going, you can get into basic statistics and plotting and even some programming, and beyond that, doing some more advanced stuff. So feel free to use this resource, but it is optional. So let's get back to the lab. And hopefully you've already been able to open up R in RStudio. Let's open RStudio. when you open RStudio, it should look something like this. You have this, what's called the console on the left. You have a window on the upper right that will tell you what objects you have in your global environment. That may not make any sense to you right now, but I'll show you in a second. And then you have this window on the lower right-hand corner that gives you, files that are in your directory that you're working in, any plots that you make, any packages that you want to install or load, and just some useful features. RStudio is basically just a wrapper for R. It just makes it a little easier to work with. R, if you opened R without RStudio, it'll just look like this, and all you have is this command line to work with. RStudio gives you some more options and better ways to kind of visualize what you're doing and working on, and hopefully it'll make life a little easier getting started with R. So the first thing I like to do is, when I start a new R project, is to just open up an R script, which is just a text file. So the R script is just a text file that records all the commands that you're giving R. So this is my first script. Well, it's not really. I have written scripts before, but this might be your first script. So I'm going to save my script because I just save kind of compulsively. So I'm going to save it because I don't want to lose any work. So I'll save it to my desktop, and I'll just call it R test, but you can call it Lab 1 or whatever you want to call it. All right, so let's get started. So I have a script. What did I do? In my first line, I just put a bunch of hashtags here, and the hashtags just tell R, don't do anything with this line. Just ignore this line. So if I run this line, if I were to hit the run button, it doesn't really do anything. And I can show you a couple of things about getting started with R. This is the console down here. This is what was when we first opened RStudio. It filled up the entire left-hand space. Now we have a script on the upper left and the console in the lower left. And the console, like I said, is what you see when you if you opened R without RStudio. But you can use the console and write commands directly in the console if you'd like. And I could write, let's say I'll make a new object. I'll call it B, and I will assign that object to the value 2. So that means I'm going to make this object B have the value 2. And so if I run that line, all I have to do to run the line, by the way, is just hit enter. Hitting enter tells R, do this command. And so this was my command to R, and look what happened in my global environment. Now I have an object called B that stores the value 2. And so what I could do is, if I typed in the letter B now, it will, and I hit enter and I run that line, you'll see that what comes out is the value 2. So R knows that this symbol B represents the value 2. And you can see that up here too. The symbol B represents the value 2. If I typed out the symbol C, which I have not yet defined, and I hit enter, R, that was not a great option for me, because C is something that R already does recognize. It's a function internally within R. What about D? Now it says D is not found. There's no object called D. So R doesn't recognize it because I haven't defined it. I could define it, and I could say D is equal to the value 3. And now I have a new object D in my global environment. So that object D now stores the value 3. And so now if I wanted to, I could say, okay, what's the value of B plus D? If I wanted to, because R knows that B represents the value 2 and D represents the value 3, so this should evaluate to 5, and it does. So I can use the console kind of as a calculator if I want. I could say, what's 3 times 3? It's 9. What's 3 to the third power? I just use the caret symbol and say, what's 3 to the third power? And I get 27. So I can use it as a glorified calculator if I want, but as I've already showed you, I can make variables. I can make variables that have more complex names if I want it. My variable is equal to the value 55. I could do that if I want. And I can do even more complex things. If I want to, I can make a second variable, and I'll assign that. By the way, this operator here looks like an arrow. It's just this less than symbol and a dash side by side, right? That's the assignment operator, and that's what you use in R to say, I want to define a new variable called this, and I'm going to define it as whatever is on this side of the arrow. So, this time I might say, let's make a whole what's called vector of numbers. So my var2 now stores every integer between 2 and 10. This colon just tells R to fill out all the integers between a lower bound and an upper bound. So 2 is the lower bound, 10 is the upper bound. It's going to say, okay, now this is filled out to be 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I type out my var2 and hit enter, I said var, my var, then it gives you all the numbers between 2 and 10. So there's a lot more to learn about R, and this is a very, very, very brief introduction. I encourage you to go through the boot camp where we go slower and we go through much more detail about the basics of using R. But in this lab, we're just kind of throwing you into the deep end, and we're going to start doing some population modeling. So what I'm going to do is just I can hit this this broom icon, and then I'll just get rid of all the items in my global environment. I don't really need those anymore, so I have a blank environment. And now we can start writing in the script. Now, why do I use the script window and not write directly into the console? Well, because this is a record of all the commands that I have run. So every line here can be its own R command. And for instance, if I wanted to say my var is equal to 55 up here, right? And I hit enter, it won't do anything because I'm not in the console. So I didn't run that line. But what I could do is hit this run button, and it will run this line. All right. And now it did the same thing as if it went directly in the console. So what I can do is, the way you can think about this is basically this command got sent to the console down here, and then it was run, and then it is now ready for me to use. I can now reference my var, and it knows what I'm talking about, and it's 55. So what's useful about the script window is that it's a text file that basically you can save, and then you have a record of every command that you ran. So if you exit the session, you close R and come back to it the next day, you could just rerun all the commands in this script, and you'd be right back to where you ended up. And so it's just a really nice way to record everything you've done in the right proper order. And so it just makes your life a lot easier. There's not anything similar if you just typed it directly into the console. Things would get messy very quickly. This just keeps things organized, clean, nice, reproducible. So I recommend using the script. There's a couple ways to run lines from the script. You can either hit the run button up here, or you could just hit Control or Command Enter, and that runs the line. All right, you can just basically put your cursor anywhere on that line and just hit Control Enter, or you could highlight the whole line you want to run and hit Control Enter. So a couple ways to do it. It's really useful just to play around with it. So I totally recommend just pausing the video and just playing around with R and RStudio, and it should start to become a little easier. And make mistakes. It's just the way you learn. Just make mistakes. Some things might not work. Don't get discouraged, and just keep keep plugging away, and try not to get too frustrated. If you get too frustrated, just reach out to me, reach out to Mia, reach out to Adriana, and yeah. So let's do some population modeling. I'm gonna again hit the broom icon. Let's just get rid of everything so we can start fresh. All right. Okay, so let's do exponential growth here. Remember, anything preceded by a pound sign, R doesn't do anything. So I could run this line. I could copy and paste it down here, run it. It's just nothing. R doesn't do anything. It doesn't recognize it. It's just a way to organize the script and make sure it's readable in a human sense. So like computer doesn't care about this, but human does. This is something that we can actually read. So this is a header. I'm just gonna notify myself in the future or anybody I'm sharing this script with that I'm modeling exponential growth. So the first thing I might want to do when modeling exponential growth, just like I did in Excel, is to define the number of years I want to model. So I'll say n years. I'll just make a new variable called n years. And actually, you know what I'm going to do? Because R is case sensitive, this is going to, if it's just easier to just not use capitals sometimes. So just for getting started, I'm not going to use capitals because I don't want to frustrate you with case sensitive things. So if you typed in a capital N instead of a lowercase n, it wouldn't work. So let's define n years. We're going to do 30 years just like we did in Excel. All right. And I'll make an population size, initial population size. I will use a capital N because we tend to use the capital N to represent abundance. So N init, I'll call it, the initial abundance is equal to 100, I think is what I put before for Excel. So let's define that as 100. So let's run these lines. So again, I could hit Control Enter, and now I have these objects in my workspace. Or if I wanted to, I could highlight them and hit Run. That would do the same thing. So now I have the number of years and I have the initial abundance, but I don't yet have the rate of growth. So I'll say R underscore D for discrete intrinsic rate of growth. And I think I set that before at 10%. So there's a 10% rate of growth. Growth is 10% per year. All right. It's always good to comment out all your lines of code here. So define number of years to simulate. And I can do hashtag here, initial abundance. So especially as you're getting started with R, it's really, really useful to comment everything out, just so you make sure you know what you're doing and what you're telling R to do. So we have now the basic things we need in order to model exponential growth. And so again, if we want to apply the discrete growth model, we might first want to define something called lambda, which is equal to 1 plus the discrete rate of growth, right? So lambda, never ran that line. So if I have to run that line before I can use it, and then I can run this line. So now lambda is equal to 1.1, and the discrete rate of growth is equal to 0.1. They're both representing 10% growth per year, all right? So they're basically representing the same thing. Now we can actually start modeling or simulating population abundance. So I can say the abundance at time 1, right, is going to be that initial abundance, and init, times what? Lambda, right? So we take the initial abundance or the previous year abundance, multiply it by lambda, we get the current year abundance, all right? So, and if I want to look at that, I can just look at it here. I can see that N1 is 110, which is 10% bigger than 100, so that makes sense. So that's the N at time 1. What if I want to simulate? This is where we start getting into computer programming. So I want to automate the process of simulating abundance, not just 1 or 2 years, but 30 years, or even if I wanted to, maybe 1,000 years. Who knows? I wouldn't want to do that all by hand. I don't want to just keep going. N2 is equal to N1 times lambda, right? And then N3 is equal to N2 times lambda. That gets, especially if I'm going to do it 1,000 times, that's going to get really, really tedious really, really quickly. And computers are really, really good at iteration. That is doing the same thing, the same task over and over and over again. Humans, we don't like doing things the same thing. It's just boring if we do it over and over again. But computers love it. Well, I don't know if they love it, but they're really good at it, and they don't really have feelings, as far as I know. So let's get into simulation. We're going to do some iteration. In iteration in R, it is done using a construct. In fact, most programming languages have a construct called the for loop. Some programming languages call it a do loop. There's also while loops, and there's other ways to do iteration, but we're going to use a for loop. So basically, when we use this construct called a for loop, we're just going to iterate the same thing over and over and over again. I will show you the syntax right here, but this is kind of the way we generally do it in R. We can pick some variable name, and that variable is going to then increment from 1 to, in this case, n years. Oops, n years, no capital, right? So for I in 1 to n years, and remember that colon just kind of like takes a lower bound and an upper bound and just fleshes out all the different integers between the lower and upper. So what it's going to do is it's going to make this variable I take the value 1, then 2, then 3, then 4, then 5. It's going to iterate all the way through this whole vector of numbers and do the same thing. Whatever I put in between these two curly brackets, it's going to do over and over and over and over again. So what do we want to do over and over and over again? We want to take some abundance value, I'll say the n current abundance is equal to the previous abundance times lambda. Now, this isn't actually correct code yet, but I'm just sort of building the code up. So what do I want to iterate over and over again? I want to take the current abundance and then or take the previous abundance, multiply it by lambda to get the current abundance, and then I want to do it again, and I'll go up to the next year, basically. I'll go to the next year and say, okay, now take the previous abundance, the abundance I computed last year, multiply it by lambda, and that gives me the current abundance. And then I'm going to increment the year again. So now it's year 5. I'll take the year 4 abundance, multiply it by lambda to get year 5. Now it's year 6. Right? And we go on and on and on all the way to year 30, right? And we go as many years as we tell R we want to go, right? So we're almost there, right? We've almost finished a simulation, but this isn't quite right because obviously R doesn't know what n current is, for instance, and R doesn't know what n previous is, and R does know what lambda is, though. So we have to define what this current and previous really represents. And so there's a couple tricks of the trade here, and I give you the code. I give you the basic code for this in the lab, so don't feel like you have to build it up from scratch. You can borrow the code that I provide and just try to make sure you understand what it does. All right, and it really would be a helpful thing if you could try to build a for loop from scratch, but it is a little challenging at first. There's a learning curve there, so don't get too frustrated if you can't build a perfect for loop when you're just getting started. All right, so I'm first just going to define the years. So all years that I'm going to model, basically, and I'll assign that to be 0. I'm going to start with year 0, right, which is the initial year, and I'm going to go all the way to year n years, or year 30, right? So if I use this colon operator, it's going to go from 0 to 30, and it's going to give me all the integers in between 0 to 30, right? So that's ultimately, I want to have an abundance estimate for year 0. I want to have an abundance estimate for year 1 all the way to year 30. All right, so now let's make an abundance vector. I'll just call it n. So n is going to represent all abundances that we predict from year 0 all the way to year 30. And the way to do that, I'm going to initialize it. So in fact, I can write that down. I'm going to initialize abundance vector, which stores abundances in every year of my simulation. All right, and so the way to do that, I'm going to use this function called numeric, and that numeric is going to have the same length or number of elements as all years. So let me run that line. I'm going to do Control Enter to run that line, although I didn't define that. I'm going to have to run both of those lines, obviously. And once I've done that, I have this vector n that is all zeros from year 0 all the way to year 30. It'll be a little clearer if I give this vector names. I can say names of n is equal to all years. And if I do that, and I just highlight n and run that line, or Control Enter it, it'll plot out or print out for me this blank vector of all zeros. But now you'll see that this first element represents year 0, the second element represents year 1, and this last element, or the 31st element of this vector, represents year 30. All right. Now they're all 0. All the abundances are 0 at this point because this is just an initial vector. This isn't my final abundances, obviously, but this is just the thing I'm going to be filling in this for loop. So this is my abundance vector. So now I can loop through this for loop. I'm going to go from 1 all the way to number of years, right? And for each of these years, I'm going to loop through year 1, year 2, year 3, year 4, all the way to year 30. And instead of n current, what am I going to do? I'm going to take this vector n, and I'm going to use this the fact that I'm in this for loop, and the way a for loop works in R, you take this vector I, this 1 through n years, and this variable I gets the value 1 the first time we're looping through this vector, and then I will take the value 2 in the next time we loop. Remember, we're going to run everything that's between the curly brackets. We're going to run the same number of times as, in this case, number of years. We're going to run it 30 times. The first time, I is going to be equal to 1. The second time, I is going to be equal to 2. And then it's just going to keep incrementing every time we loop through this. Every time R iterates this for loop. So this notation here, and you can learn more about this in the R bootcamp, and this is just kind of a basic R thing. It just takes a little while to get comfortable with. When I use the bracket notation, it means I'm going to take a certain element of a vector. So if I said n and I put a 2 between the brackets, it's going to give me the second element of this n vector. Of course, they're all 0 right now, but they, just for illustration, I could define the second element of n to be equal to 10, and then you see that the second element of this vector, which happens to represent year 1, is now equal to 10, right? So this is how we reference a particular element of a vector. So in each time I'm looping through this for loop, I'm going to take these, let me just remake this n vector. So now they're all zeros again. We're going to start at year 1, right? So the current year abundance is equal to the previous year abundance times lambda. Before we go any further, let's actually take the first element of n, which represents year 0, and define that as the initial abundance. N init, I think is what I called it. N init. And now we can see that the the year 0 abundance is 100, and now we have zeros all the way through. Now we can use the for loop, right? So we can take in year 1, n bracket 1, year 1, we're going to define that as the previous abundance, which is not n bracket 1, it's n bracket now I minus 1. If I is 1, this means that n year 1 is equal to n year 0 times lambda. And then we're going to increment. So now I is equal to 2. We're in year 2. N bracket 2, year 2 is equal to n bracket 2 minus 1, which is equal to 1. So n at year 1 times lambda. Then we increment again. And now I is equal to 3. We're in year 3. And abundance in year 3 is equal to the abundance in year 2 times lambda, and so on and so forth, all the way to n years. Now, the only problem we have here is that, remember that we're starting with year 0 here, and then we go from 1 to 30. That is year 1, year 2, year 3, all the way to year 30. But when we're talking about the elements of a vector, where you see that actually the first element of this vector is actually representing year 0. The second element is representing year 1, and the 31st element is representing year 30. So instead of looping from 1 to n years, what we're going to actually do is loop from 2 to n years plus 1. And I'll put that last bit in parentheses just to make sure it's doing it right. So we go now from 2 to 31, and so now this should work correctly, because now we take the second element of the n vector, which represents year 1, and that is computed by multiplying year 0 times lambda, and so on and so forth. So this just may seem slightly confusing, but this is how this is one way to make it work. Now, one thing about computer programming in general is that there's always many ways to do the same thing, which is kind of a nice thing, because it means that if you can't do something one way, you can probably figure out another way to accomplish the same thing. So don't feel like the code that I'm giving you is the one and only way to accomplish the task. If you want to go ahead and be creative and try something different that could also accomplish modeling or simulating exponential growth in R, by all means, go for it, and I would love to see what you come up with. But let's run it. So again, let's go from here to make sure everything's run properly. Now I have run a for loop, and you'll see now this n vector is not all zeros anymore, but instead year 1 is 10% more than year 0. Year 2 is 10% more than year 1, and so on and so forth. And by the year 30, we have about 1,745 individuals. One thing we did in Excel that we can do in R as well, if we want, is just make sure that we're representing whole individuals, not fractional individuals. I don't like seeing 285.3 individuals, because 0.3 is not a very good number of individuals. So what I'm going to do is just round, and so I'm going to define n as a rounded version of n. So I'm just going to basically just take all the integers. So now by year 30 we have 1,745 individuals, which is exactly what we found in Excel and in Google Sheets. So before we end, let's just plot out abundance over time, just like we did in Excel. I'll just use the plot function, and on the x-axis I'm going to place the years, which is 0 to n years, and on the y-axis I will place n, and I can just run that line now if I want, and I can see exponential growth. It's not maybe a pretty figure, but it's a start, and if I want to start making the figure look nicer, I could give it a x label. It's equal, I'll say time years, and that changes the x label to be time years. the y label is probably okay, just n. I could change it if I want and say y label is equal to abundance. And now I have improved the figure a little bit. And if I want to, I could say type equals L, basically to make a line instead of points. So there's a lot you can do with plotting. I'd encourage you to look over the boot camp. There's a lot more on making pretty plots, really nice looking plots. There's a lot you can do with visualizing data in R. It's a really good tool for that. And that's pretty much where we got to with Excel. Obviously, this was a very quick and not very thorough introduction to R, but hopefully it'll get you started and at least get you started with the lab. Again, the more you play around with this, the better. Don't get too frustrated. Let me know if you have any questions or run into any technical issues. And I look forward to working with you in lab.